Humans have looked up at the night sky for millennia. When you look up night after night, you can't help but see certain patterns. Humans are, after all, pattern recognition machines. It's how we learn, grow, and improve ourselves as we get older. What patterns do we see when we look up at the night sky? Today, we're going to look at the motion of the stars and planets as we observe them from Earth. The stars in the sky stay in approximately the same positions relative to each other. Orion is always near Taurus. Ursa Minor is always surrounded by Draco. The stars don't move relative to each other much at all. They're a constant background painting as we look at the sky. There are some subtle movements, however. As we orbit the Sun over the course of the year, stars that are nearer to us move left and right a little more than stars further away. It's a subtle effect, but it makes sense. If you walk down the street and look in the distance, you'll notice that faraway objects don't move much relative to you when compared to nearby objects. This is what naturally happens with things at different distances. In fact, we can use this effect to calculate the distances to some of the nearby stars by a method called parallax. Parallax is where we measure how much a star moves while we orbit around the Sun, and use that information to calculate the distance to that star. However, these movements are not the most significant ones we observe as we look at the stars in the sky. While the background painting of stars stays basically the same, the whole painting moves every night. Over the course of a night, if you watch the stars, you might notice that they make a circle. In the northern hemisphere, every star in the sky circles around the North Star, Polaris. In fact, if we take a really long exposure with the camera, we can see the star trails this motion creates. It looks like what you're seeing on screen now. Why do the stars circle around the North Star? Well, the stars aren't really moving at all. It's really the Earth that is rotating. The axis of the Earth's rotation goes through the North Pole and South Pole. That's why the stars appear to move around a point that's directly above the North Pole, the North Star Polaris. That star is nothing special, it's just a star that happens to be right above your head when you're at the North Pole. In the southern hemisphere, there's a similar pattern. The stars appear to rotate around a point directly above the South Pole. The only difference is that there isn't a South Star. There just happens not to be a visible star directly above the South Pole. The planets are different. Each of the planets orbits the Sun like we do, and moves relative to us day by day and month by month. Their motion in the sky is quite separate from the stars and also quite complex. Like everything in the sky, they rise in the east and set in the west because of the Earth's rotation. But the exact position they're at in the sky at, say, 10:30 p.m. will be different from one night to the next. They slowly drift across the sky day by day because of their orbit around the Sun relative to our orbit. The planets that are closer to the Sun than us, Venus and Mercury, spend about half their time moving east across the sky day by day, which is called direct motion, and half their time moving west, which is called retrograde motion. This is because they're orbiting the Sun as we watch them. They move east, pass by the Sun, then move west, and pass by the Sun again. They're really circling the Sun. It's just that the sky appears flat to us. The planets further away from us are a bit more complex. They spend most of their days drifting west to east. After not being visible for a while, they return to the sky and go west to east all over again. But there is a brief time when each of the outer planets does move the opposite way, east to west. It's like a little dance they do now and again, and causes their path across the sky night to look like what you see on screen now. This happens when we catch up with the planet and overtake it briefly. This diagram shows how it works. Mars does this most often, at least every couple of years, since it's so much closer to us. The outer planets have much more subtle retrograde motions. This motion was one of the first pieces of evidence that we orbit the Sun. Explaining this strange dance is easy if you assume everything orbits the Sun, but explaining it with everything centered on Earth is much harder.
The
stars in the night sky stay in approximately the same positions relative to each other. They move slightly due to an effect called parallax, which is where we measure how much a star moves while we orbit around the Sun, and use that information to calculate the distance to that star. But neighboring stars are always neighbors. However, the whole star field moves together in the sky in the course of each night. In the northern hemisphere, every star in the sky circles around the North Star, Polaris. The stars aren't really moving at all. It's really that the Earth is rotating. The axis of the Earth's rotation goes through the North and South poles, and that's why the stars appear to move around a point that's directly above the North Pole. In the southern hemisphere, there's a similar pattern. The stars appear to rotate around a point directly above the South Pole. The motion of the planets is separate to the motion of the stars. Like everything in the sky, they rise in the east and set in the west because of Earth's rotation. But night by night, their position at a given time changes because of their orbit around the Sun. The planets closer to the Sun than us spend half their time in direct motion night by night, the movement of the planets from west to east from our perspective on Earth, and half the time in retrograde motion, the movement of the planets from east to west from our perspective. They appear to move back and forth as they orbit around the Sun. The Sun is in the middle. The planets further away from the Sun than us mostly drift west to east. But there's a brief time when each planet will go east to west in a little loop. This happens when we catch up with the planet and overtake it briefly. Mars does this most often, at least every couple of years, since it's so much closer to us.